Hello everyone, in this video we're going to learn how to solve this challenging integral. Alright, we need to calculate the antiderivative of s plus 1 over s squared plus s plus 1 altogether squared. Alright, so observe that the top we have s plus 1, the bottom we have s plus 1 right here. Then we need to rewrite the top as integral of s squared plus s plus 1 then minus s squared. Alright, so basically you just add and subtract the same s squared. Alright, over s squared plus s plus 1 altogether square ds. Alright, now I can split this fraction into two fractions. Alright, so it turns out to be, I wrote this guy and this guy right here. So it turns out to be 1 over s squared plus s plus 1, right? ds minus the integral of s squared over s squared plus s plus 1 altogether square ds, right? Alright, now this one right here, we need to turn the denominator into a complete square. Alright, so basically I have s squared plus s plus 1 is the same thing as s squared plus s. Now I'm going to add 1 over 4 and minus 1 over 4 and then plus 1, right? So the first three terms right here becomes a complete square. So it's going to be s plus 1/2 altogether square, right? This guy becomes 3/4, right? Alright, so this one can be written as the integral of 1 over s plus 1 over 2 altogether square plus 3/4 ds, right? Now the second one right here, I can factor denominator. So I have s squared right here. The denominator right here, I factor s squared out, and you see that you have square right here, so it turns out to be s power 4, right? So s power 4 right here, and then it turns out to be 1 plus 1 over s plus 1 over s squared altogether square ds, right? This guy right here, I can rewrite it, so it's going to be 1 over s plus 1/2 altogether square plus, this one turns out to be root 3 over 2 altogether square, right? And then ds right here, I can write ds as d of s plus 1/2, right? So then I can apply the formula. Now this one right here, I just simplify this guy and this guy, right? So I have s squared left right here. So this guy can be written as the integral of 1 over s squared over 1 plus 1 over s plus 1 over s squared altogether square ds, right? Now the negative side right here, I can bring this inside, and then I turn this one into positive, right? Now the bottom right here, I can turn this one into a complete square, so it turns out to be what? So you have 1 over s squared plus 1 over s plus 1 equals 1 over s squared plus 1 over s plus 1 over 4, right? Minus 1 over 4 add 1, right? So I just add and subtract 1 over 4. Now the first three terms right here becomes a complete square. So it could be 1 over s plus 1/2 altogether square. This guy turns out to be 3, 4, right? Alright, so the first one right here, I can apply the formula. The integral of du over u square plus a square equals 1 over a tangent inverse of u over a plus c, right? Now in this situation, u, which means s plus 1/2, right? And a, which means root 3 over 2, right? So it turns out to be 2 over root 3 tangent inverse of 2 over root 3 times s plus 1/2. Alright, so we finished the first one. Now we need to calculate this one right here. So I bought this one, right? So this guy turns out to be the integral of negative 1 over s squared over this guy right here. I replace with this, right? So it could be 1 over s plus 1/2 square plus 3, 4 all together square ds, right? Now this guy right here, I can write as root 3 over 2 altogether squared, right? Observe that if I take the derivative of 1 over s plus 1/2, it turns out to be negative 1 over s squared ds, right? So I just replace this guy right here with this guy, right? So I call this guy as I, right? So I have I equals the integral of 1 over s plus 1/2 altogether square plus root 3 over 2 altogether square, right? And the whole thing right here square, right? And d of 1 over s plus 1/2, right? Alright, so observe that this guy is the same thing as 1 over u squared plus a squared, right? So in order to calculate this one, we just use substitution. We let u equals a tangent t, right? So then, now we use the trigonometry substitution. So we let 1 over s plus 1/2 equals root 3 over 2 tangent t, right? Now we take derivative both sides, right? So we have d of 1 over s plus 1/2 equals root 3 over 2 secant square t, right? Now secant square, which means 1 plus tangent square t, right? So this guy turns out to be root 3 over 2 times 1 plus tangent square of t dt, right? Forget dt right here. Now we substitute this guy back into the original one right here. So we have I equals the integral of 1 over. Now if you square this one, this guy square. So it turns out to be 3 over 4 tangent square t plus 3 over 4, right? Altogether square. And then this guy turns out to be d of this one equal this one right here. So it could be root 3 over 2 times 1 plus tangent square of t dt, right? Alright, so now next, the bottom one right here, I have 3 over 4 tangent square of t plus 3 over 4 altogether square. Now I factor 3 over 4 out. So because you have a square right here, which means you factor 9 over 60 now, right? So it turns out to be tangent square of t plus 1 altogether square, right? So 9 over 16, I print it to the front, it turns out to be 16 over 9. And then you have root 3 over 2 right here, so it will be root 3 over 2, right? So this guy right here becomes integral of 1 over tangent square of t plus 1 altogether square. The top you have 1 plus tangent square of t, right? And dt right here. Now this guy and this guy cancel out, right? So you have this guy cancel out, so you have 8 root 3 over 9. The integral of dt over 1 plus tangent square of t, right? Now 1 plus tangent square of t equals 1 plus sine square of t over cosine square of t, right? So this guy turns out to be cosine square of t plus sine square of t over cosine square of t, right? And then this guy turns out to be 1 over cosine square of t, right? So this guy turns out to be 8 root 3 over 9. The integral of dt over 1 over cosine square of t, right? Alright, so you have I equals 8 root 3 over 9. Now 1 over cosine square of t, I just flip it, so it turns out to be integral of cosine square of t dt, right? Now this guy equals 8 root 3 over 9. The integral of 1 plus cosine of 2t over 2 dt, right? Now you simplify this guy and this guy. 8 divided by 2 is going to be 4, right? So you have 4 root 3 over 9. And you take antiderivative of this one, it turns out to be t plus 1/2 sine 2t plus c, right? Now we need to substitute the original variables back into this guy, right? So previously we used the substitution by letting 1 over s plus 1 over 2 equals root 3 over 2 tangent t, right? Now we need to divide both sides by root 3 over 2, so it turns out to be tangent t equals 2 over root 3 times 1 over s plus 1/2, right? Now we need to take tangent inverse both sides, right? So tangent inverse of this guy equals tangent inverse of this guy, right? So it turns out to be t equal to tangent inverse of 2 over root 3 times 1 over s plus 1/2, right? Now we substitute this guy for t back over here. So we have I equals 4 root 3 over 9 times tangent inverse of 2 over root 3 times 1 over s plus 1/2, right? And then now plus 1/2 right here, sine of 2 parentheses, and you copy this one down. So it will be tangent inverse of 2 over root 3 of 1 over s plus 1/2. Alright, so this is the answer for I. Now we bring this guy over here. And then we have the final answer. It's going to be this guy right here and this guy right here. And it's your time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us high.